Okay, so let's see. This is in this I'm going to discuss with you metal forming questions of previous year gate exam. So you can see here the first question during open die forging process using two flat and parallel dies, a solid steel block of initial radius 200 mm. So RIN is nothing but this is 200 mm. And let's suppose if I draw its figure, this is the upper die. Our upper die, correct? And this is our lower die. Lower die. And in this we have a cylindrical billet. Like this. So this is the condition for compression, yes or no? And after compression you can see after compression when your tools moves from, you can see here, from here to here. This is the condition, final condition, in which the billet can be compressed like this. Yes or no? Then its diameter will increase and its height will reduces. Is that clear? This is initial condition. This is initial condition, and behind this we have final condition. Is it clear? So you can see, if I draw a center line, correct? So this radius is called as initial radius, and this radius is called as final radius. Sorry, this is initial radius and this is final radius, which is denoted by RI, and this is initial and this is final FN. Somewhere in between this, here we have one situation at which the stick friction converted into sliding friction, and this is the radius at which, and this radius is nothing but is called as RSS, means radius corresponding to sticking friction, means this is the point at which before this point, for this here we have sticking friction, and after this we have sliding friction. Yes or no? Here mu comes and mu comes under picture, and here we have m. Are you getting this point? So actually we need to calculate this radius, correct? So you can see here IRN is 200 and RFN we need to, sorry, if I write height of the billet, initial height of the billet, that is HIN, which is meter, and HFN is given here, that is 30 millimeter. First we need to calculate RFN in millimeter. So you can see here these things are given here. Now the some conditions are also given. The coefficient of friction mu is nothing but 0.5 in bracket 1 plus e to the power 1 plus e to the power minus RIN over RFN. So this we can calculate coefficient of friction, correct? And obviously in this region here we get sliding friction. So I'm not interested in this, correct? And this is also not useful data. This is extra data. So in this question they ask if you can see here in this condition 0 when r is varying. What is r? R is a radius of any location. So when r is varying from, and you see at the center here we have r is 0, and at this point the r is RSS. Up to this the sticking friction condition occurs, and after that it changes from sticking friction to sliding friction. So here we need to calculate RSS. So for determination of RSS, here we have one relation, and that is nothing but is equal to RFN. Here I am writing formula RFN minus HFN per mu. Mu is the sliding coefficient of friction in bracket, sorry, ln 1 by mu. So this is the expression for determination of radius from which the sticking friction changes to sliding friction. Yes or no? And mu is the sliding coefficient of friction, and for this here the formula is given here. So in this relation you can see only RFN and mu is unknown, and for mu we just have this formula. First we need to calculate RFN. So for determination of RFN, so here I am applying law of volume constancy. Law of volume constancy, it tells us the volume before deformation is equal to volume after deformation. Volume after deformation. Is it clear? Before deformation is equal to volume after deformation. Correct? So volume before deformation is nothing but this is area of cross section, that is pi by 4, or simply you can say in terms of radius pi r in square into h. This is the volume of cylinder and this is h in equal to pi r fn square into h fn. So from this r fn can be written as RIN square root of h in over h fn. Yes or no? Now if we put the value on this expression like this, Rin is 200 square root of 3 by 30. After solving this, here we get RFN is nothing but 258.198 millimeter. Yes or no? And after getting this final radius, we just use this formula to get RSS. So RSS is nothing but this is equal to RFN, that is 258.198 minus HFN, that is 30 over 2. Yes, before getting this, first we need to determine mu. Yes or no? And the relation for mu is also given here, and from that relation mu is written as 0.35 in bracket 1 minus e to the power rin minus minus 200 over 258.198. Is it clear? So by putting these values, when you simplify it, and here you will get mu is equal to 0. Mu is equal to 0.5133. 5113. Correct? And after getting mu, now you can able to find RSS, and the formula is already given here. RSS is nothing but this is RFN, which is 258.198, correct, minus HN, that is 30, by 2 into mu, that is 0.5113, ln 1 over mu, like this. Correct? And let's, here I am thinking this. Okay, so let's suppose here I am putting this value. Okay, so now if you simplify this expression, so from this here we get RSS equal to 204.63 millimeters. So which one is the right answer? Option B is the right answer. Option B is the right answer. Option B is the right answer from this discussion, correct? So it can be determined like this. Okay, so let's see another question. The thickness, width, and length of the metal slabs are given. Hence, that is T to 50 mm. Width T is equal to 250 mm, and length, that is LF is, sorry, L 600 mm. Yes or no? Respectively, a rolling operations on the slab reduces the thickness, and here we perform rolling operation. So can I say this is original width, original thickness, and original length, initial condition? And when you perform rolling operation, then the slab reduces thickness. Thickness is reduces by, means final is equal to, the thickness is reduces by 10%. Reduces by 10% means how much remaining we have, that is 90%. So can I say this is 0.9? 90% means 0.9 times initial thickness, that is 50 millimeter, and obviously here we get this is 5 millimeter, and increases the width by 3%. Thickness is reduces but the width is increases. So the final width is nothing but this is 250 into 1.03. This is final width, correct? And the length of the rolled slab is, so we need to find out LF. Again, we need to apply law of volume constancy. Get clear? Law of volume constancy. Simply from this we can say V naught is VF, and V naught is nothing but this is K into 3600 is equal to, when I say this is 0.9 into 50 into 1.03 into 250 into LF. You can say this 50 and 250 is cancelled out with this. So after the calculation of this, here we get LF is equal to, let me check, LF is equal to zero point 0.9 into 1.03 and 300 over this. So the final length will be 883, correct? 3883.495 millimeter. This is the final length. The final length. Is it clear? 0.9 into 1.03. Yes. 3600 over this. 3883.495. This is the correct answer. So like this, you can solve this question. Very simple question. Here we only apply the volume law of volume constancy. Okay, so let's see this question. A 200 mm wide plate having a thickness of 200 wide plate means width of this plate is 100 mm, thickness is given as it is 20 millimeter, and is fed through a rolling mill with two rolls. The radius of each roll, radius of the roller is given here, that is 100 mm. The plate thickness is reduced to, let's say this is not, and if I say TF, then this is 18 millimeter. In one pass, using the rolling speed n is also given, that is 50 rpm. The strength coefficient K is given here, that is 300 megapascal, and then hardening exponent is also given here, that is 0.2. Coefficient of the rolls and the plate is 0.1. If the friction is sufficient to permit the rolling operation, means there is no need of external applied force to push the billet, yes or no, or plate. Then the rolling force, here we need to calculate rolling force. How much rolling force may act for this? Correct. So you can see here, rolling force. Rolling force is nothing but rolling stress into rolling stress into area. Correct? What area you can see if from rolling like this? Like this, correct? So actually we need, if I project this curved surface, then it is looking like this. Is it clear? So here we assume this is the projected area. The projected area perpendicular to this, here we have force F, that is rolling force, and this is projected area. Is it clear? And what about this projected area? This is nothing but this is LP, that is projected length of arc. Actually we have this arc, yes or no, but we use this projected area only. So LP to width, yes or no, correct? So from this, here we need to calculate sigma as well as LP. So obviously from power law, and this is sigma bar, not sigma. Sigma bar is nothing but this is K epsilon to the power n over n plus 1. Is that clear? And here height is reduced from T0 to TF, and the force is acting along the thickness. Can I say the true strain is nothing but this is ln. ln. Obviously we can write final height over initial height, but here I am writing initial height, initial thickness to final thickness. Obviously this is understood, this value becomes negative. Why? So this is compressive, that's why I am writing initial upon final, otherwise you just write final upon initial. Yes or no? Simply here we get ln 20 by 18, and when you solve this, then here we get, let me check, ln 20 by 18, this is 0.105. Correct? This is strain, and once you get a strain, from this we can calculate mean flow stress, which is equal to 300. K is already given here, 0.105 power n, that is 0.2 over 1 plus 0.2. Correct? So after simplifying this, here we get mean flow stress is nothing but from this we get 159.395 megapascal. And what about LP projected length? This is root of R delta H. And radius of the roll is given here. And instead of writing delta H, here we can say this is delta T. Or yes, delta T. I'm not changing that thing. You can also write delta T. So this radius is given, that is 300. And what about delta T? This is 2 millimeter. Delta T is F, sorry, T naught minus TF. And this is 20 minus 18. So here we get 2 mm. Yes or no? So LP becomes square root of 600. 24.49. 4948 millimeter. So now we can solve FF, which is equal to sigma bar, which already we have determined, that is 159.95 into LP, that is 24.4, and width is also given here, that is 200 millimeter. Correct? So after, and we need this value in kilonewton. So can I multiply with 10 to the power minus 3, so that directly we can get this value in kilonewton? Yes or no? So you can see here, after calculating this, here we get this is equal to 780.872 kilonewton. The right answer. Is it clear? So like this, you can solve this problem from rolling process. Okay, so let's see another question. A bolt has to be made at the end of rod of diameter D is equal to 12 millimeter by a localized forging. By localized forging upsetting operation, the length of the unsupported portion of the rod is 40 mm. To avoid buckling of the rod, a closed forging operation has to be performed with a maximum die diameter. You can see here the die diameter is nothing but when you can see here we have one relation, that is if L is greater than 3 times of diameter, and obviously this is 40. Here length is 40. 40 into diameter is 12. Sorry, times of diameter. So length is 40 and this is times of diameter, that is 12. Correct? So here we get this condition, yes or no? Length is greater than 3 times of d. So whenever we have this condition, then the diameter can be written as die diameter 1.5 times of simple. You just put this 1.5 into 12. So after simplifying this, here we get 18 millimeter. So 18 millimeter is the right answer. Correct? So next you can see the thickness of a sheet reduced by rolling without any width using 600 mm diameter rolls. So let's suppose thickness of the sheet is reduced by rolling. So this is a rolling process. First you write this is a rolling process. Width any and the width without any change in width. So this is a plain strain rolling. Plain strain rolling means width strain along width the direction is equal to 0. That's why this is called as plain strain rolling. Neglecting elastic coefficient of rolls and assume that the coefficient of friction between the workpiece, that is mu, is given here, that is 0.05. The sheet enters the rotating rolls unaided with the initial sheet thickness means h naught is 2 millimeter. The minimum possible final thickness hf can be produced in a single pass of rolling. So if I apply self-entry condition, and you can see using 6 diameter rolls, so the radius of the rolls is also given here, that is 300 mm. If I apply self-entry condition, because there is no external force applied, so it is written as mu square into r greater than equal to delta h. Correct. So from this we can determine delta h should be less than equal to 0.05 square into r, and this is nothing but this is 300, and delta h is nothing but this is h naught minus hf. So from this hf can be written as h naught minus mu square into r, that is h naught is given here how much, 2 mm. So minus 0.05 square into 300. After simplifying this, here we get 0.05 square into 300 and 2 minus this 1.25 thickness. So HF becomes 1.25. Clear? This can be obtained, and actually here we need to minimum possible final thickness. Here we need to write minimum final thickness. So this is 1.25. The right answer. Okay, so what about next question? The cold forming process in which a hardened tool is presented against the workpiece when there is relative motion between the tool and the workpiece produce a roughened surface. The regular pattern is, so this is nothing but this is knurling operation. Correct. Next, a plate in strain compression of a block is shown in the figure. The strain in the z direction is 0. Strain, you can see this is xy and this z direction, and the strain along z direction is equal to 0. The yield strength Sy in the uniaxial tension compression material of the block is given here. Yield strength Syt equal to Syc is equal to 100 megapascal, and follows the Tresca criteria, that is MSS theory. According to MSST theory, under plane strain condition, can we write, suppose if you apply compressive load along this direction and the stress induced along this direction. So the compressive load is nothing but this is sigma y minus of sigma x. This is equal to SYC, because this is a case of compression. So simply here we use SYC. Yes or no? And what about sigma y? Is minus 40. Sorry, sigma x, not sigma. Actually, we have this relation sigma x minus sigma y less than equal to S by S. Yes or no? Max minus sigma y by 2 or sigma x minus sigma y by 2 is less than equal to S by S by 2. Sorry, S by S, or instead of S by S we can write S by T or S by C by 2. Yes or no? So from this it can be written as sigma x minus sigma y less than equal to S by T. Is it clear? So from this if I see, from this can I say, and since this is a case of compression load, so instead of we can use S by T, here we can use S by C. Compression, correct? Because tension and compression are the same. Here you see, here we have minus 40, that is 40 compression load already given here, minus 40 compression, minus sigma y less than equal to minus 300. So from this, okay, S sigma y is nothing but, minus sigma y is nothing but, and why, oh, why I am writing this? The strength need not to represent by negative sign. This is a strength. So simply here we can write 300. Correct? 100 plus 40. Correct? Because this is a material property. And from this sigma y can be written as less than equal to 300, 40 megapascal, or we can say sigma y is equal to 40 megapascal, and with negative sign this is compression. Obviously along the y direction we have compression. Yes or no? So the correct answer is option A. Okay, so next you can here consider the stress strain curve for an ideal elastic plastic skin hardening metal. As shown in the figure, the metal was loaded in uniaxial tension starting from O. See here, correct? Start loading from here to here. Yes or no? An ideal elastic strain hardening metal, as shown in the figure, the metal was loaded in uniaxial low tensile starting from O. Upon loading, the stress strain curve passes through the aid point at P and then strain hardened to point Q. Where the loading was stopped, from point Q, the specimen was unloaded to point R. So this is loading and this is unloading. And this is the final condition where the stress is zero. If the same specimen is reloaded in the tension, means again if we load this tension, from the point R, then the value of stress at which the material hits again. So whenever we have this kind of situation, then metal always starts hitting from the previous point. जहाँ से आपने अनलोड किया है वही हमारा न्यू एट पॉइंट बन जाएगा. दिस इज कॉल्ड एज एस बाई टी एस and this is our old S by T, tensile stress. The correct answer for this question is S by T S is, that is 210 megapascal. The correct answer. When you load the sample up to a certain plastic limit and unload it, and again if we reload, then follow same path, and here the Young's modulus is same, and yielding begins from which, जहाँ से आपने लोड अनलोड किया था वहीं से ये फिर से यील्डिंग स्टार्ट होगी. तो जो प्रीवियस लोडिंग पॉइंट था वही आपका न्यू यील्ड स्ट्रेंथ होगा. यस और नो? सो द करेक्ट आंसर इज 210. मैच द फॉलोइंग प्रोडक्ट्स टेबल मैन्युफैक्चरिंग प्रोसेस. टूथपेस्ट ट्यूब, it is made by impact extrusion, so P4. Metallic pipes are made by centrifugal casting, this is 1. Plastic bottles, this is made by blow molding, sorry this is 2 not 3. And thread bolts, obviously it is made by rolling. 4123 options, the right one. Okay, so let's see another question. The true stress sigma, true strain epsilon diagram of a strain hardening material is shown in figure. First, there is loading up to a point A. Means first we have performed loading up to point A up to stress of 500 megapascal and strain zero point 0.5. Here we have strain 0.5. Then from point A there is unloading up to point B. Unloading up to point B, that is the stress of 100 megapascal corresponding. Here we have stress 100 megapascal. The Young's modulus is 200 GPa already given. The natural strain at the point B is. Need to calculate this. So upon unloading, this much amount of strain recovered. Yes or no? Correct. So remember one point. Whenever you load the sample and unload it, the Young's modulus remains same. Young's modulus before deformation is always equal to Young's modulus after deformation. Is it clear? And this is equal to 100. K means 10 to the power 3 megapascal. Is it clear? So you can see here we have triangle from triangle ABC. You can see this is the right angle triangle, and from this right angle triangle, can I say if here we have an angle theta, tan theta, which is equal to per BC. And what is tan theta? Tan theta is nothing but slope of stress strain curve, which is nothing but this is called Young's modulus. You can say this is A after deformation. A after deformation. Nothing but from this, can I say B is nothing but this AC per E times of after deformation. And what about AC? 500 minus 100 over Young's modulus is given here, that is 100 into 10 to the power 3. So when you solve this, then here we get 400 by 200 divided by 1000. This is 0.002 millimeter, or not in millimeter, this is strain. Correct? So we get BC. So what about epsilon B? Epsilon B is nothing but can I say the epsilon at C minus, and this is 0.5 minus 0.002. From this epsilon we get 0.498. The answer 0.498 is the answer. That right? Okay, so let's see another question. The maximum reduction in cross section area per pass of a cold wire drawing process is given here. That is R is equal to, you can see here, R is equal to 1 minus or minus n minus plus 1, where n represents the strain hardening coefficient. For the case of perfect plastic means, you can see here the material can deform like this. This is called as perfect plastic. Means in the perfect plastic there is no strain hardening. So can I say n is equal to 0? So here we need to find out what is R. R is nothing but this is equal to 1 minus e to the power minus 0 plus 1. Simply here we get 1 minus e to the power minus 1, or we can say 0.12. The absolute value. So the correct answer is option D. Is it clear? Okay, so let's see another question. A bar is compressed to half of its original length. Means L naught is equal to, let's say, L. LF is nothing but this is L by 2. The magnitude of the true strain. So true strain is nothing but this is L and LF by L naught. And write this is L by 2 over L, or simply you can say ln 1 by 2, and this is nothing but it gives us minus 0.693. Correct? ln 0.5 gives us 0.693. Correct? 0.693. This is the right answer. This is the right answer. Is that clear? In a linearly hardening plastic material, the true stress beyond initial yield. Linear is linearly hardened plastic material. Linearly hardened plastic material. So the correct answer is linearly increases linearly with the true strain. Means like this. Linearly hardened plastic material like this. This is elastic strain and this is plastic. So here we have linear plastic increasing linearly with true strain. Yes or no? So option A is the right one. This is the desire to make product having T-shaped cross section rectangular aluminum. So the best process is metal forming. Okay, so next a cup 10 millimeter deep cylindrical cup with diameter of 15 mm is drawn from the circular blank, neglecting the variation in the diameter of the blank is. The diameter of the blank is nothing but it can be determined square root of d square plus 4dh. So this is nothing but this is square root of d square, that is 10 square plus 4 to 10 into 15. So simply here we get 26.457 millimeter, the blank diameter. This is very simple question, like this you can solve it. Okay, so next shearing strain of the mild steel sample is recorded 0.1%. Then what about true strain? Strain is nothing but this is ln 1 plus e. Correct? So this is given in the percentage, so right in form. So it can be written as ln 1 plus 0.1 into 10 to the power minus 2. Correct? You just divide with 100. 0.1 divided by 100 plus 1 ln this. It gives us strain is nothing but the engineering strain of a mild steel sample is recorded as 0.1%. The true strain is 0.1%. Then true strain is. Okay, so this gives us 0.009, sorry, 0.099%. Sorry, not 0, 9.995 into 10 to the power minus 4. And if you want to represent this system percentage, so it's simply you multiply with 100 and it gives us percent. So simply here we get 0.099. So don't forget to write this term from percentage to fraction form. Yes or no? The correct answer is option C. Okay, so next question is the flow stress the megapascal of a material is given by this, where epsilon is a Young's model elastic material. So let's say sigma is given here, that is 500 into epsilon to the power 0.1. Correct? And the Young's model given here, that is 100 GPa. A block of thickness 100 mm made of this metal compressed to and this is PF, that is 95 millimeter, and the load is removed. The final dimension is, so after removal of load we need final dimension. F prime is, so simply you can say here we have a case of this. So initially you perform some strain up to this. After that you just remove the load. That this much amount of recovery takes place. Yes or no? Amount of recovery takes. And this is the total strain, and this is your actual final strain. This final strain, and this is recovered strain. Yes or no? The final strain first we need to calculate, that is epsilon minus recovered strain. Correct? So you can see here, let's suppose this is A and C. So from triangle ABC, can I say the Young's modulus is nothing but that is slope, which is equal to AC over BC. From this, BC can be written as AC. What is AC? So first we need to calculate how much stress we have corresponding to this, and which can be determined by this. So from this, sigma is nothing but this is 500 epsilon, and for this again we need first strain. So first we calculate two strain, and two strain is nothing but this is ln LF by L naught or F by T naught. Then it can be written as ln TF is 95 and T naught is 100. So from this here we get 95 per 100 and ln is 0 point, and obviously here we get minus signs, but I omit this minus sign because this only signifies the nature of this strain, that is compressive. So this strain can also be written as 0.05129 compression, and once you get this, then sigma can be written as 500 into 0.05129 to the power 0.1 to 500. Here we get sigma is equal to 171.514 megapascal. Correct? And after that, once you get this, from this, okay, here I am writing epsilon is nothing but this ln TF by, or can I simply write T naught by TF? I am writing this, which is ln 100 by 90, and this gives us 0.059. Obviously this is compression, so from this this can be written like this, and once we get this stress and strain both, now can I say from the triangle, right angle triangle ABC, Young's modulus is nothing but this is AB by BC. So BC is nothing but this is AB, which is nothing but this is 371.514 over Young's modulus, which is already given at the 200 GPa. So from this BC can get 0.00185. Yes or no? And once you get BC from this equation, you can say BC is nothing but the amount of covered. Yes or no? So the final strain is nothing but this is epsilon minus epsilon R, and epsilon already we have this 0.05129 as 0.0018. So epsilon F is equal to 0.0519 minus 0.0018. After simplifying this, 0.04943, correct? And this nothing but this is ln final thickness over initial thickness. Correct. So from this, can I write the final thickness is nothing but exponential to the power 0.04943 into final initial thickness, that is 100. So from this we can get final thickness. Once again here I am writing epsilon f is equal to ln T naught by T. Understood this compression. So from this, if I write, so TF is nothing but this is not over power final strain 100 over e to the power 0.0493. So from this, when you simplify this, then you will get 95.177. Correct? This is the correct answer. Ninety-five point 177, your final answer, like this. Okay, so next question. In a two-stage wire drawing operation, the fractional reduction ratio of change in cross-sectional area to initial cross-section area of the first stage is 0.4. Change in cross-sectional area means delta A over A naught is equal to 0.4. So it is nothing but this is A naught minus AF by A naught, 0.4. So 1 minus AF by A naught, AF by A naught is equal to 1 minus nothing but A naught times 0. Yes or no? The fractional reduction in the second stage is 0.3. So let's say this is final one. In the second stage reduction, if I say, so the calculation for this is nothing but can be written as F1 is the initial height for the initial area for the second one minus AF2 over AF1, this is equal to 0.3. If I write F2 by AF1, then here we get 0.7. Correct? So AF2 is nothing but 0.7 times AF1, or you can say 0.7 into 0.6 times A0. AF2 by A0 is 0.7 into 0.6, 0.4. And if I subtract 1 from both sides, A minus AF2 by A0, 1 minus 0.4. Simply it can be written as A0 minus AF2 by A0 equal to 0.5. Correct? So overall, this is overall fractional reduction in area. So the correct answer is option B. Correct? So I think, are you getting the question? Okay, so let's see another question. The slab rolling operation, the maximum thickness reduction delta max is given by this. Is also given here in this question, where the r is the radius of roll, mu is given here, mu square into r is equal to delta h maximum reduction. Mu is given, that is 0.1. The maximum angle subtended by the deformation zone at the center of the roll is. So here we need to determine alpha. So as you know that cos alpha is nothing but this is 1 minus delta h by 2. Correct? So from this relation, can I say delta h by r is nothing but this is mu square, or simply we can say delta h by r is equal to 1 square or 0.01. So from this cos alpha can be written as 1 minus 0.01 by 2. Don't forget to write this. So from this here we get cos alpha. To solve it, why I am writing this. Okay, so this is 0.01 over 2, 1 minus this cos inverse. So here we get 5.79 degree. Correct? But first you see whether this angle we need degree. Yes, the angle of bite in degree. So this is the right answer. The right angle answer. So this is the key point. Yes or no? And don't forget to write this, because here we have delta h by 2r, but this relation is delta h by r. Is it clear? Yes or no? Now you can see another question. The strain hardening exponent n of stainless steel SS304 with a distinct yield and UTS value undergoing plastic deformation. So you just remember the n always varying from 0 to 1. Correct? Next, as the following products perfect manufacturing process. Rails are engine crankshaft, aluminum channel, water bottles. Water bottles are made by this blow mold. Let's say this is, so this option is wrong. Correct. Next, aluminum channels are made by extrusion process. This is R2. So R2. So this option is also wrong. Correct. R2. Next, engine crankshaft. Engine crankshaft, obviously it is only made by crankshaft. It is made by forging process. So Q3. Is there any option? Yes, Q3P. So the correct answer is option P. Rails are made by rolling process. A metal rod of initial length L0 is subjected to a drawing process. The length of the rod at any instant is given by, you can see here, length of the rod is a function of T, which is equal to L0 1 plus T square, where T is the time in minutes. To strain rate, here we need to find strain rate, and this strain rate is nothing but this is d epsilon by dt. Yes or no? D epsilon by dt. Correct. So LT is given here, L is given here, that is L0 1 plus T square, and if we get this, then here we get L0 T into D. Yes or no? Correct. And strain is also written as, strain is nothing but, can I say strain is nothing but this is dl by L. So dl is L0 into 2T to dt over, and can I say this is fractional strain, d epsilon is equal to dl by L over L0, and where L0 is nothing but this is, L is nothing but this is L0 1 plus, so this L0 is cancelled out with this. Can I say this is dl by dt is equal to 2t over 1 plus t square? Yes or no? 1 plus t square. Is it clear? And this d epsilon by dt is nothing but this is epsilon. Epsilon is equal to, here we need to find out the true strain rate at the end of 1 minute. At the end of 1 minute. So here we put equal to 1. 1 over 1 plus 1 at t is equal to 1. Correct. From this here we get 2 by 2, that is 1 per minute. 1 per minute. Is that right? So the correct answer is 1 per minute. Here strain rate. Sorry, strain rate. Next, with respect to metal working, match group A and group B. Defect in is defects in rolling. Defect is product of screw rolling. Rolling is meant for producing ball bearing balls. So let's suppose. And catering is a defect of rolling. So Q1 is the right option. Q1 rolling seamless semi-finished balls. Yes, semi-finished balls of ball bearing. So that in screw rolling is 6. Defect in screw next Q1 R6. Q1 R6. Only one option is there, that is correct. 3 defect in extension is physical defect and product of rolling through cluster mill. So it is used for producing thin sheet with tight tolerance. Correct. Cluster mill. Correct. Cluster mills, you can say it is looking like this. The main roller through which deformation takes place, and in the backup we have many rolls. This is called as cluster rolling. Is it clear? This is called as the cluster rolling, and the cluster rolling is used to produce sheet with a closed tolerance. Is that clear? The correct answer is option B. And screw rolling mainly making ball bearings ball. Remember this. Okay, so the relation between true strain, that is epsilon T, and injury, that is epsilon E, a uniaxial tension test is given by. So the yes, true strain is nothing but this is ln 1 plus epsilon T. Epsilon 1, yes, option C is the right one. Epsilon T is ln 1 plus epsilon E. In a rolling process, the state of stress of the material undergoing deformation. In rolling process, remember, the material can be deformed. Material can be deformed by application of compression and shear. In a single pass rolling process using a 10 mm diameter steel rolls, if I talk about radius, then it becomes 105 millimeter. Strip of width is, that is 140 millimeter, and thickness naught is, let's suppose this is h naught. Like the thickness represented by h. This is 8 mm. Undergoes 10% reduction of thickness. So HF is nothing but this is 0.9 times 8, or simply we can say 7. The angle of bite, here we need to write alpha. So this is very simple question. Cos alpha is 1 minus delta h by 2r. Yes or no? Here we get 1 minus delta h is 8 minus 0.2, that is 0.8 by 2r, that is diameter of the roller. So from this calculate, then you will get the answer. And obviously here we need to write this angle in radian. So whatever we get from this, it will be converted into radian by multiplying pi by 180. So from this here we get 3.579 degree, but we want this angle in radian. So 0.579 to pi by 180. Alpha is equal to 0.062 radian. 0.062. Yes, so C option is the right one. Okay, so let's see next question. In a multi-pass operation of a round bar of 10 mm diameter and 100 mm length is reduced in cross section. 10 diameter D naught is given, that is 10 millimeter, and length also given, that is 100 millimeter. Cross section by drawing the drawing process success series 7 dies, means this is 1, 2, 3, 4, 5, 6, 7 die. 3 not die. 7 dies, okay, no issue. Let's suppose the die 1. Correct. Okay. We enter this rod with its initial diameter, final diameter. Initial diameter, this is final diameter. Correct. During each of the drawing process, the operation, the reduction in the cross section is 35%. You can see here A naught minus reduction in cross section area. Naught minus AF by A naught is equal to 0.3. So simply from this we can write AF is equal to 0.5 times A. So this is 1, yes or no? If I write AF2, then it becomes 0.5 times of AF1, and can I write this is 0.65 into 0.5 into A naught AF2. Similarly, if I write AF7, then it becomes into, we have 2 times of multiplied of 0.6 in 7 times, then 0.65 to the power 7 into A naught. Correct. The total true strain, so AF7 by A naught is nothing but 0.65 to the power 7. Are you getting this? Why I am writing this relation? So from this here we get AF7 by A naught is equal to 0.65 to the power 7. Correct. So the true strain is nothing but this is ln A naught by AF to the power AF7. Correct. So epsilon is nothing but this is 1 ln 1 over 0.65 to the power 7. After simplifying this, here we get, from this here we get 3.0154, the final strain. First part of this question, think the true strain applied in the final length, and similarly we also need to find out final length. What about final length? So from this, as you know that if I apply volume constancy, then this V naught is equal to Vf. Can I write V A naught into L naught is equal to LF7 into A naught F, sorry, AF7? Yes or no? From this, LF7 is equal to A naught is pi by 4 d square 10 square. And why I am writing this when I have already A naught by F7? Yes or no? Or what about A naught by AF7? So AF7 by A naught is this. So 1 over 0.65 to the power 7 into this gives us LF7. 1 over 0.65 to the power 200. So it becomes so 39.88 millimeter. Correct? According to the correct answer is option C. Correct? Option C is the right answer. Correct? The procedure for solving this question. Next question, you can see in a rolling process, the roll separating can be decreased by reducing the roll diameter. Roll separating force is nothing but this is stress into area, is LP into width, and LP is nothing but this is R delta H. Yes or no? So reducing the roll diameter, yes, by reducing the diameter, we can reduce the rolling force, increasing the friction between the roll and the metal. No, there is no term. Reducing the front tension, provide backup rolls. Correct answer is reducing the roll diameter. By decreasing the roll diameter, we can reduce the roll separating force. From this formula, can I say this is inversely proportional to R? Sorry, directly proportional to the root of R or diameter. Yes or no? Hot die still used for large solid dies in drop forging should nearly necessarily have hot die steel used for large solid dies in drop forging should necessarily have high strength and high copper content, high strength, low hardenability, high strength and low thermal conductivity, high hardness and high thermal conductivity. So high hardness, hot die still used for large solid dies in drop forging necessarily high toughness, yes, high toughness and low thermal conductivity is the right answer. Why we need high toughness? Because in the drop forging, huge amount of impact force may act, so the die metal should be tough. And low thermal conductivity indicates the heat transfer also decreases. So the billet can be heated for a long time period. Anisotropy in a roll component is caused by change in dimension, scale formation, closure of defects, grain orientation. This inner anisotropy, the main reason behind this is grain orientation. Correct. Next, 10 mm diameter any steel wire is drawn. Wire is drawn through a die at a speed of 0.5 meter per second. Reduce the diameter 20%. The power required in the drawing. So you can see here, force required for drawing can be written as sigma naught ln naught by AF. Correct. And F is equal to sigma naught is given here, that is 800 megapascal. Ln, you can see here 10 mm diameter and wire is drawn through a die of which is the diameter is 20% reduces. So this is diameter. And what about A naught? Can I say this is nothing but this is Ln? It can also be written as D naught by DF whole square. So D naught is 10 and 20% after 20% reduction. Here we get final diameter is 8 mm and this is correct. So this is force. Then what about power? Power is nothing but this is into velocity. So this is ln 10 by 8 whole square into velocity, that is 0.5. Yes or no? This gives us power. Correct. So let me check. And the yield strength of the material is 800 megapascal. Bar required for drawing process. Oh, this is not force. This area, this stress. Stress. Is it clear? This is not force. And want to write drawing force. Obviously, it can be written as Fd equal to RT into final area, because in the drawing process the billet wire, yes or no? Correct. And similarly, if you write power, so the power is nothing but this Ft into T final. And you can see the die at wire is drawn through a die at a speed of this. So this is final velocity. So sigma d into AF into F, or we can say more precisely sigma naught ln d naught by df whole square into af. And what about af? Pi by 4 df square into f. Now from this we get the power, and this is 800 ln 10 by 8 whole square into pi by 4 8 square into, and it's just 4 Newton into velocity, that is 0.5. Now obviously here we need to write this value in kilowatt. Simply we can divide this value with 1000. Correct? That is 10 to the power minus 3. So this gives us in kilowatt. So power is nothing but, you can see here, gives us, you can see 800 ln, right, ln 8.97. This gives us 8.975 kilowatt. Correct? So this is the procedure. Here I am writing each and every step to solve this question. Correct? The correct answer will be option A. Okay, so let's see another question. Okay, this is the second part of the previous question. Neglecting the friction and instead hardening, the stress required for the drawing is. The drawing stress is nothing but this is sigma naught ln A naught by AF into, sorry, A naught by AF only. Sigma T is equal to 800, and obviously instead of this, can I write this is ln D naught by df whole square, 800 ln 10 by 8 whole square. So from this here we get 357 029 Pascal. Option B is the right choice. Okay, so let's see another question. By application of tensile force, the cross-sectional area of the bar P was reduced by 30% and then additionally 20%. By the application of tensile force, the cross-sectional area of the bar P first reduced by 30%. Cross-sectional area means A naught equal to, let's say, A, then AF1 is 0.7 times of A. Yes, or A naught, or simply you can say this is original area or initial area. So this will be 0.7 times A naught. Then by an addition 20%. Addition 20% means AF2 of 0.7 into A naught. इसका 80% रिडक्शन होगा तो बचेगा कितना? तो सिंपली वी कैन से into 0.8. So final becomes this 0.56 times of 8. Another bar Q of the same metal is reduced in cross-sectional area by 50% in a single step. So this is first bar and this is another bar. और ये बार कैसा था? This is a bar P. So this is calculation for bar P. Now if I write for calculation for bar Q, so if an original area is A naught, correct? So AF is nothing but 50% reduction in single step by applying the tensile force, means AF is 0.5 times of A naught. After deformation, the true strain in the bar P and bar Q is. So the true strain of bar P can be written as ln A naught by AF2 equal to ln A naught is, let's say, suppose A naught and AF is 0.56 times So from this here we get 0.5798. Obviously compression hoga, this is compression, and EQ if I write, then this is ln A naught by AF, which is ln 1 by 2, sorry, A naught by 0.5 times of this ln 2 compression. So 0.5798 or 0.58 and 0.6. Yes, option is the right answer. Okay, let's see another question. A rolling strip is reduced from 4 mm to 3 mm using 300 mm diameter. And rolls are rotating at 100 rpm. The velocity of the strip at the neutral point is v. So listen, velocity of the neutral point, velocity of the strip at the neutral point is same as the tangential velocity of roller. Is that clear? So V of the material, V of the strip is equal to V of the roller, and V of the roller can be written as pi dn by 60. Pi dn by 60. Correct? So VR is nothing but, or V of the strip is nothing but, this is pi, diameter is given 300 and N is given 100 rpm divided by 60, and suppose here we need to represent it in meter, simply we divide with 1000. You can see these three zeros, you can this. So from this, the strip velocity is nothing but it is 3 times pi, that is 1.57 meter per second, right? The option A is the right answer. What about this? A copper strip of 300 mm width and 300 mm thickness to be rolled to a thickness of 295 mm. Copper strip of 200 mm width and 300 mm thickness, H naught is 300. Initial dimension is rolled to a thickness of 195 mm. The rolls of radius 100 mm. Rolls of radius 300 mm. Rolls of radius 300 mm rotates at rpm and is equal to 100 rpm. The average shear strength of the work material 180 megapascal. The roll strip contact length and the roll force are. Roll is contact length. Roll is contact length means here we need projected length and F. As you know that projected length LP, but this is square root of R delta. So the rolls radius is 300. Okay, so square root of 100 into delta H. Delta is nothing but this is H naught minus HF, that is 300 minus 195. So simply from this here we get LP is equal to pi into 300 square root of 1500, 38.73 mm. This is the projected length. Now next task is to determine roll force, that is shear strength into shear area, that is A. What about A? A is nothing but this LP into V. 180 into 38.73 into width is given, that is 2. And if I divide by this value with 1000 to convert this value in mega newton, so 10 to the power 6. So simply here we get F is equal to 1.3942 mega newton. Correct? So the correct answer is option C. Okay, so let's see. Assertion reasoning. Cold working of metal results in increase in strength and hardness. Yes, it is right. The cold working reduces the total number of dislocation per unit volume. This is wrong. When you perform working, the number of dislocations will always increase. So A is true, but R is false. Consider the following statement in comparison of hot working in cold working. Means cold working में hot working के comparison में क्या होता है? High force required, yes. No heating is required, wrong. Less ductility is required. Better surface finish is obtained, yes. Better surface finish is obtained. 1 4 जिसमें ऑप्शन में हो तो वही आंसर सही. B is the right one. It's absolutely wrong. And इन दोनों में 4 ऑप्शन नहीं. That's why option B is the right. Okay, so round billet made of brass is to be at 700 degrees centigrade. The billet diameter is 100 mm and diameter of the extrusion is 500. The extrusion force required is, you can say in this, the extrusion constant, let's say sigma bar is given here, or you can say sigma naught equal to 250 megapascal. At 700 degrees, the billet diameter is, initial diameter is 100 mm and the diameter of the extrude is 50 mm. The extrusion force required. So extrusion force is nothing but this is sigma naught ln d naught by d whole square into initial area, that is pi by 4 into naught. Correct? So and obviously here we need to write in mega newton. So can I multiply with 10 to the power minus? So sigma naught is given here, that is 250 ln, what is d naught? This is 100 by 50 whole square into pi by 4 into 100 square into 10 to the power minus 6. After simplifying this, we get the result. So let's suppose 0.72 mega newton, 0.726. Very simple question you can see here. Option C is the right answer. Okay, you can see a lever having 90-degree bend to the bend is to be produced by drop force using mild steel bar of raw material. The various operations to be performed: cutting, bending, folding, blocking, and de-aging. So remember, the first step is soldering. Next, aging. Third step is bending. Fourth step is blocking. Correct? So according to the arrange, then first soldering, so this is R, then aging, that is T, then bending, that is Q, then blocking S. Anything else? Then cutting, yes, P. R, T, Q, S, P. B is the right answer. Is it clear? So these are the steps. Blocking, after blocking, we always perform finishing and then trimming, which is called as cutting. Okay. Okay, what about this? Flash and gutter are provided in the drop forging dies of the following stage. In the blocking stage, correct? Blocking stage. Old set may occurs in the product obtained. Old set is a defect of thing. The extrusion process for production lab. Old set, it is written here that is lab. So for this, correct choice will be forging. In forging, actually, what will happen at the sharp corner when you deform the material, then it get reversed back, and if not used properly, then this is called cold set defect. Yes or no? So this one is the right, most appropriate. The extrusion process used for production of two-phase tube, that is impact extrusion, forward extrusion, and tube extrusion. So the correct answer is impact extrusion. Impact extrusion. Only three. Option D is the right one. Impact extrusion is mainly used for making toothpaste tube thin section. Sorry, thin. Cold working product produces the following effects. Stresses are set up in the material, grain get distorted. Strength and hardness of the metals are decreases. This is wrong. यहाँ पे भी 3 है. Correct. Surface reduce. This is also. So the correct answer is 1 and 2. So the option A is the right. Which one of the following manufacturing process requires the provision of gutter forging process? Closed die forging. Option A. Moving mandrel is used in wire drawing operation, tube drawing operation. Moving mandrel is used in tube drawing operation. Thread rolling is restricted to ferrous material, ductile material, hard material. Restricted to thread rolling can be done in the ductile material. Hard material cannot be thread rolled. Semi-brittle material can be extruded by hydrostatic, and this is a straightforward question. The blank diameter used in the thread rolling will be equal to the major diameter, little higher than the minor, little higher than the pitch diameter. Major diameter equal to the major diameter. Correct? Collapsible tubes are made by extrusion process. Use impact extrusion. Okay, so match the following. Coining, wire drawing, blanking, deep drawing. Coining process में लोड अप्लाई करते, blanking, wire drawing process, tension and blanking operation here. Correct. So shear means this 2, this 1, this 4, 412, 412. So the correct answer is option A. The operation in which oil is permitted into the process powder metallurgy, impregnation. Let me check. Yes, impregnation is the right answer. I actually confused with infiltration. The correct answer is impregnation. In infiltration, we actually dip the powder metallurgy part in a powder so that density can be enhanced. But in impregnation process, the powder metallurgy product is dipped into the oil to increase its self lubrication ability. The maximum possible draft in the cold rolling of the sheet increases with, you can say, a delta H is less than equal to mu square into 1. From this we can get the answer. By increasing the coefficient of friction, yes, this is right. Decreasing wrong, decreasing roll radius wrong, increasing roll velocity wrong. The correct answer is option A. The force required in a blanking operation of low carbon steel 5 kN. The thickness of the steel and the diameter of the part is D. For the same work material, if the diameter of the blank part is increased to 1.5 D, then the thickness is reduced by 0.4 T, the new blanking force. The blanking force you can see here, this is nothing but stress into area. And here we cut a circular sheet. So this is ID into T. So FP is directly proportional to DT because this is made up of same material. FB by FB1 is equal to D2 T2 over D1 T1. And what is D2? 1.5 times of D. And what is T1? 0.4 times of T over dt. So this d is cancelled out with this. So simply here we get fv2 over fv1, or simply here we need to calculate fb1. Sorry, fb2. So fbt is nothing but this is 5 kilonewton into 1.5 into 0.4 points. So this is kilonewton. So option is the right answer. Option is the right answer. Match the following: blanking, straight forming, coining, tapering. In the coining we have compression only. In a stretch forming we have only tension. This is 1. In blanking we have only shear. This is 3, 3, 1, 2. 3, 1, 2. Option D is the right one. No need to write it. That's this. Correct. Now in next question you can see the thickness of the metallic sheet reduced from 16 mm, means H naught is equal to 16 mm to final value of 10 mm in single pass rolling with a pair of cylindrical rolls, each of diameter 400 mm. Then the bite angle is alpha. So simply you see cos alpha is nothing but 1 minus delta H by 2r, and 2r is nothing but this is diameter. So 1 minus 16 minus 10 over 400. So after solving this, here we get, and we need this value in degree. So this is 6 over 400, 1 minus this, and cos inverse of this. This is 9.93 degree. Yes, 9.936. The correct answer is option D. Next you can see in open die forging, a disc of diameter 200 millimeter and height 600 millimeter. Open die forging, a disc of diameter means D naught is given, that is here, and height H naught is 60 millimeter, is compressed without any barreling effect. The final diameter of the disc DF is 400 mm. The true strain is, you can say true strain is nothing but obviously the force acting along the height, so the true strain can be written along the height itself. So HF by H naught, and from volume constancy if I write V naught is equal to Vf, so can I say this is H naught into A naught is equal to AF into HF, correct? And V is given here, so HF by H naught can also be written as A naught by AF, yes or no? From this the strain release can also be written as ln HF by H naught. Instead of HF by H naught, here I am writing A naught by AF. So you can see here this ln A naught by AF is also written E naught by AF whole square. Correct? Why? Because this is pi by 4 d square. Pi by 4 cancel out. So D naught is 100 by 400 whole square. So here get minus 1.386. And this minus sign indicates compression. So option C is the right answer. Okay, wrinkling is mainly due to insufficient blank holding force. Orange is mainly due to large grain side. Temperature strains due to yield point phenomena, and earring it is mainly due to excessive blank holding. 4316. 4316. 6 here I am. Earring, okay. Earring is mainly due to planar inertia, not tearing takes place due to excessive. This is 2. Yes, so option D is the right one. Okay, match the following. Next is molded luggage packaging containers for liquid long structure shapes collapsible tube. Flexible tapes are already, I know that it is made by impact extrusion, so S3. So these two options are wrong. Correct? Long structural shapes only produced by either extrusion or rolling. So hot rolling is the most appropriate. So 3 are 2. So correct answer is B. Correct. Molding luggage made by transfer molding. This is plastic manufacturing method. And Q5, that is packaging containers for liquid blow molding, not blow molding. Huh? Yes, blow molding. Correct. So option B is the right one. A test specimen is stretched slightly beyond the yield point and then unloaded. Its yield strength increases. You can see yield strength always increases. You can see here it is looking like this. Unload it. Again, if you perform loading, then this is your old yield strength. This is new yield strength. S by T, and this is at by T prime. The process of hot extrusion is used to produce the process of hot extrusion. Curtain rods, steel pipe of domestic water supply, stainless steel used in furniture, large size pipes used in the correct answer is option C. Curtain rods made of aluminum can also produce by hot extrusion. Yes, and stainless steel tubes used in furniture can also produce by hot extrusion process. Is it right? In forging operation, the sticking condition occurs near the center. I already solved one question, first question, correct? Sticking friction always at near the center. Why? Because at the center the heat transfer rate will be minimum, and always comes into picture when the ductility of the metal is more and the temperature is more. Yes or no? So the sticking friction always occurs in this zone only, the region where sticking friction takes place. Correct. So this is all about all question of metal forging metal forming process.